we're going live. We're live to solve a couple of LeetCode problems. Well, let's see if we can do one first and maybe the other one after. But these two problems are from our Saturday club that I attend, and I kind of saw the logic of the solutions, but at the same time, I didn't fully get it. So it's kind of cheating, but not fully cheating. But what's good about it is that I think those problems are somewhat interview format problems. So it's not just like 2 pages of code problem with some combination of algorithms who nobody knows. So something super magical and special. Well, and so we have two problems. One of them is easy level, the other one is medium level. Let's start with the easy level, and let's see what we can do. Let's target for an hour with something. now we're plus. Hour plus. And now we're plus. Yeah, so let's look at this problem. A minimum number game. You are given an array, integer array. Okay, of even length. And there is also an empty array. Okay, Alice and Bob decided to play a game where every round Alice and Bob will do one move. The rules of the game are as follows. Every round, Alice will move the minimum element from nums, and then Bob does the same. Now Bob will append the removed element to array. So initially it started with Alice going first, and now Bob goes first in the second part. And then Alice does the same. So he appends his elements. The Bob will append the removed. So he is removed, I guess. The game continues until nums becomes empty. So if we look at the tests, so we have this input, and if we sorted this 2, 3, 4, 5, Alice will take 2, Bob will take 3, Bob will put 3, then Alice, then again Alice will take 4, and Bob will take 5, Bob will put 5, and Alice will put 4, and they can go up to 100 like that. And in the second test example, 2, 5, and Bob goes 5, 2. So what I think we're having here is basically this will be 2, 3, 4, 5. Then those pairs are swapped, but the result will be so it will be 2, 3, 3, 2, 5, 4. Anyways, I mean, this swapping, disregard the swapping. I mean, it's just a basic it's pretty much you need to swap them. But before you do that, you need to sort them. So what I'm thinking how to do it without the sorting, and I don't think it's, I mean, okay, nums are from 1 to 100. Oh, well, yeah, well, we can do count sort here. Mm-hmm. Mm-hmm. Yeah, which is a linear time sort, because we know it's 100. Yeah. So are they all unique, those numbers? Integers array nums are from 1 to 100. I don't think they're unique. Yeah. And is it okay? It's okay. Yeah, it's okay. We'll do just count sort. We'll say that our frequency array I can use slice or array here, doesn't really matter. If we make a slice of integers of length 101, so we have the index, and we'll go over the nums. We don't need their indexes. We only need their values. Is range nums. And we'll range over nums, and we'll say frequency array value plus plus. So now we have all the numbers, their count in this frequency array. So how frequently they appear. Now we can we'll be extracting our values from that array, and one way we can do that is we can actually extract them and get our sorted array, and then just do the swapping. By the way, if the numbers are the same, how will that work? I think it's just, if they're the same, we just don't need to swap them, basically. Or we just swap everything. We don't, I mean, it's the same thing. It doesn't matter. The logic is Alice takes the minimum, Bob takes the minimum available. Yeah, but can we extract them from that frequency array into our result? Make array of integers length nums can we extract them in this order with that? I mean, swapped already. Yes, we can. I don't know. I think we should simplify it. Yeah, I think we should do the first task first. Like, So we will be going over the yeah, we'll have a pointer. Yeah, we do need to go over the result. Because we'll be writing into result, range result. Now we'll need a pointer in our frequency array. And we can call it current, or we can call it J, whatever. Yeah, so we are ready to write into result I. We need to take something from our frequency array, current, but we need to check if it's not, so if it's more than 0, yeah. So basically we need to search over that frequency array. We can do, I guess we can do 2 pointers. Like, we can do it like that. Yeah, so let's do it a bit different way. Yeah, so for I less than length of result, and we just for cur less than length of frequency array, but it shouldn't be necessary. But what we will do is go like, okay, if frequency array current is 0, then continue. What's up with the indentations? And continue. Yeah. So now it will just jump to the value. Now we have some value in our frequency array, and we take that value. But we need to say what? Yeah, we need to say current plus plus, and that will give us the number. Current will be the number. So now we know it's the count is not 0, so current is the value we can put into our result. So we will say result current, result I, and by the way, we need to track, by the way, yeah, we need 2 pointers, one in our result and one in our source array, in our frequency array. So let's call them, we need some good naming here, because I mean, what is current? Well, we can call them, yeah, in result we'll call them I. In source we'll call them current. But I mean, yeah, we probably should rename them. But yeah, so let's do the, yeah, let's do. So we say result is current, and we need to say that frequency array current minus minus. So we took that value and we put it in our, we put that into our result, and we took it from good. Good. Yeah. Now we need to do the swapping, basically. We'll go over the, well, yeah, we'll have for I will be, we'll start with a 1, I less than length of result, I plus plus. So we'll start with the first. Oh, what if there is only one number? Oh, no, there is at least 2 numbers. So never mind. Yeah. Yeah, result will be at least 2 numbers. And we're gonna say that the result we're gonna swap them, yeah. I minus 1 is result I minus 1, result result I, and return result. So that should be what we need. Okay, there is a bug. Let's try to find what the bug is. Yeah, on an interview, you might not see that, but see the output. But in this case, you can. And what happened is, okay. So where could be the problem? Okay, is it the sorting? Because this part is essentially the sorting. We take nums. Yeah, when we do the sort count sort. Yeah, count. We can we call this slice count sort? So we have the slice. The slice now has, and by the way, we first, yeah, we got to code at 15 minutes. Now we're just debugging it. Yeah, we're going over the nums and counting them. Numbers, their indices. For their indices, we're just counting them, yeah. And then we have a result. So that segment, let's see if we can also, yeah, is the swapping working right? So we start from the first, say I is minus 1. Previous is current. So it looks like the bug could be somewhere here. So we're creating, yes, this result. of length, of the needed length. Now we have 2 pointers. One of them is going to be on our result. By the way, we can call it, instead of calling it result, we can call it sorted. Here, sorted. Because then we will swap them. Yeah. Essentially, this is sorted. Yeah. I'm not sure we might be, yeah, so we have this, I is basically result index. I don't know if it's readable. J is current, we can call it J, will it help? I don't know. Yeah, current is the source. So we will go as long as we are within. Oh, by the way, are we moving our indices? So current is our index on the source array. Yes. It's moving. I think we never moved the I. Yeah, so we put the I. We say that result I is current. We remove I plus plus. Yeah, we need to move the I here. Now it's better, but not. Still not. Okay, so if source has something. No, it doesn't. If it hasn't, we just skip it. You move the current and go to the next. If it's, yeah, so this will make sure we get to the source that actually has something. Now, when it has something, we put it in our result at the current index. We remove it from the source and we move the index on result. Now go to the next and we'll line them up. Yeah, once it hits the 0 again, we go looking for the next number. And this way we will distribute them along our result array. That should be working. But print line pay, and we wanna font print line result. I want to see what they'll look like. So result is actually well sorted, yeah, after that. Swapping doesn't work. What's wrong with the swapping? Result I becomes previous, which I is 1, and previous becomes current. And we go until the last one. Oh, gee. Oh. How we move along that path is important. Yeah. Yeah, so this, yeah, we have the details, all these details to take care of. Yep, so count sort, and that, I mean, we do take the memory, but we could actually take less memory if we wrote, instead of writing into result, we could write just write back into the nums. Okay, so yeah, but it's not a big deal. Yeah, but if we needed to save that memory, we would just use the nums again. Yeah. So yeah, we can pretty much replace result with nums. And instead of, because we are, yeah, it's our little optimization. So we can look for result and replace it with nums for all, and it should do. Yep, and bits 64, but let's see bits. Yeah, so we're fast and furious. The power of count sort. Wonderful. Wow. 25 minutes was enough to, with all my rusty mind, with my, to warm it up a little bit, was enough to deal with this easy level problem. I guess it's a good target for the medium level problem, I think, that's time. But let's go to the medium level problem. I need to reshare. Yeah. And by the way, I want to move. Yeah, let's do a little stretch and move our workstation to that table, because the glow, the reflection in this, in the screen, are messing with me. The reflection. So, and also that's a little bit of a stretch. So we don't just, a little stretch. Nice. That's, by the way, the lighting here is much better. Power source. Yeah, I was surprised how much power streaming consumes. So, anyways, there is this medium level problem. Construct string 2182. 21. Construct string with a repeat limit. Repeat limit. All right. Let's restart our clock. So basically, in this problem, you are given a string that is a string of lowercase English letters, string S. It's up to 10 to 5 characters. And so yeah, because I already looked into the requirements. So this is a little bit of cheating. And you need to construct a new string, repeat limited string, using the characters of S such that no letter appears more than repeat limit times in a row. You do not have to use all characters from S. I'm trying to understand why. I mean, because you need to return a lexicographically largest. And larger means that that it's later in the alphabet. Yeah, so like larger, B is larger than A, lexicographically. So dictionary logic, yeah. I mean, if larger, that's why I'm thinking like, because also A is smaller than AA. So to get the larger, and AA is bigger than A, that like get larger. Yeah, let's look at the input. We have the string where there is 1A, 3 C's, letter C appears at most. Oh no, so that's the result. But in the initial array, yeah, we had 4 C's, yeah, 2 what we have here, yeah, C is 4 times, Z is 2 times. By the way, Z is the highest, so that's why we start with Z. Then we have A, right? A is once. Yeah. I don't know why you do not have to use all characters from C, because the more you use, the larger the string, as I understand it. We use all of the characters to construct the repeat limited. Hence, no letter appears. Yeah, but when they construct it, they use C 3 times, then A, because 3 is the limit, then A, and then back to C again. Hence, no letter appears more than the repeat limit times, and the string is valid. It's the largest, so we return. Note that this is larger, but the C appears more than 3 times, so it's not valid. Okay, in this example, it's example 2. Maybe that answers my question. In this example 2, oops. we have B is 3 times, and A is 4 times, as far as I can count. Limit is 2, and they go like 2, A, B, A. We use only some of the characters to construct the repeat limit. The letter A appears at most 2. The letter B appears at most 2. No letter appears at most than the limit times. So it's valid. Why is it the largest? Is the largest possible, so we return. Note that the string is larger, but the letter A appears more than 2 times. Now I see. Yeah, that's the thing. Yeah, we have more A's to add. So that's larger, but we have limit, so we're limited. Okay, the solution, when you see there is some kind of priority, I mean, you want to start to make sure you're starting with the bigger letter, lexicographically a lot bigger letter. Yeah, you need that. You need that priority. Need that priority. And I mean, we can also do the frequency array, because we're dealing only with the English letters, lowercase English letters, so we can do a frequency array. And yeah, like that. And we'll go from the end of it, like start collecting and spreading them. Start with the bigger ones and putting them into our result. So we'll put like Z. Then we can like have a count until the limit. Yeah, track the limit once we hit, like CC, then we hit the limit. What happens in that case? We need to go, basically we need to go to the next. Yeah, we'll have this Z, X, Y, X, and we'll be moving in that direction. If Z hit the limit, we'll go to Y. And yeah, the logic, once Y hits the limit, we can go back. So we want to have we want to track we want to track the maximum. Yeah, but what could happen is we could we go and search for the next one. When that hits its limit, we can go back. We will search back if there is something that higher than that, yeah, on our priority. If there is something higher than that. Mm-hmm. 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 We're working on the logic for this, for the solution. Yeah, basically, yeah, it's a search. Yeah, so we go to the right. Yeah, first we start with the highest in this queue. By the way, yeah, why queue? Because queue is, order. There is the beginning and the end of the queue, and things are added at the end of the queue. And that's what should be happening, right? Like, but I mean, if the thing is, if we take from the QZ and we go to the next one in the QY, once we are done with Y, we need to go back again from the, yeah, we first, and by the way, the same thing with Z first. Okay, once we were done with Z, we need to look first if there's anything before it. So what's at the top of the queue? And if there's nothing, if Z is at the top, we go looking for the next one after the Z. And once we hit the limit on that, we do that again. We check what's at the top, try to exhaust that. So we always try to exhaust the highest, yeah, until we hit the limit. Then we go back to the biggest ladder available. And overall, there is like 10 to 5. So n squared is going to be too much. What we know, yeah, I mean, but there is like the number of them is n squared, but we know there's only 26 letters. So actually, if we just do this iteratively, we should be fine, I guess. Yeah. We're having them sorted. I mean, in this, so we just start with the highest, exhaust it. I mean, exhaust the, hit the limit. If we hit the limit, then we'll again check we check the if there is higher available. Basically, we check anything that's available, that anything higher than, or anything start in this order. Yeah, we'll go through them starting with the highest one. And if we have to do that 10 to 5 times for each value, that will be n by n by 26. So basically this is n. Because, yeah, 26 times, I mean, we will just need to go over the alphabet. Yeah. Essentially. Yeah, essentially this is going over the alphabet. All right. Yeah, get me the highest outside of the one available that's not just that's outside of the one that's been just where we hit the limit. Yeah. Yeah, I think that's kind of the way to go about it. So let's see if we can implement that. So we need, we'll have this ABC, our alphabet. And by the way, can we use some other data structure to do this queue? If we queue them up, like, yeah, we can queue them up like Z, but when we restart, like we hit the limit, we don't go to the smaller one, we go to the bigger one as well. So this queue, it's more like a priority queue. Yeah, we need to know what's at the top, what's available, and start with it all the time, what's available. And we do that with a linear complexity. We start and just find it in our alphabet. Alphabet. If I can spell alphabet, yeah. Can I spell alphabet? Yeah, alphabet. I think I got it. Yeah. So our alphabet, well, it's just not just, it's the character count, basically. Character count, char count. And that char count will be within offset, but we'll have it as make slice of what? It's a slice of integers of length 26. And we'll go over for over the string s. Yeah, but we need to say that v, this it will give us a rune minus a, rune of the a. Yeah, so this is how we'll count these chars, characters. All right. Now we have that. Now we need to build by the way, can we use like a stack? Well, stack allows you like to, you pop at the top, when we build our result, CCAC, we'll get to 3. That moment we don't, we put them, we are stacking them up, but we're just not, are we popping anything? We don't need to, I guess. Yeah, I'm trying to see where I can use just the basic queue or a basic stack if there could be valuable here. I'm not sure we need to. Yeah, we'll just need to go for. By the way, we could also use. Instead of using a slice, we can use a map, but so we will need to go over this char count. Yeah, we will just start from the end of it all the time. Yeah, we'll go over for length of char count -1 and I bigger or equals 0, I minus. So that will produce us the maximum. If char count I bigger than 0, that's what we need. Another thing is also we need is that it's not this current character. Is going to be yeah, this and char count I and also I not equal current. Well, that, yeah, the one that hit the limit. Yeah, we want to bring that to the, yeah, that's what we will need. I 0. Oh no, I will start with the at the top of our queue. So yeah, we'll say break, and that will give us that character. Yeah, that character, the biggest character to work with. That hmm Uh-huh. Before we do that, yeah, but this current, yeah, we worry about it only when there is actually when we hit the limit. The current character might not. And by the way, this is sort of similar, yeah, with the previous problem. We'll be looking for the, yeah, we'll be sourcing those. Yeah, we're building this result, and this result is going to be a slide make slice of byte. Okay. By the way, it could be just one symbol. Yeah. Make a slice of byte, and we'll need that. We will go for over the, but we will restart. That's the thing. We'll restart. So we're building that slice of byte, and we'll repeating that until until, yeah, if we ran out of numbers that we can use, yeah. And those are yeah, so we'll have this for I character. Yeah. Character will start with the last one. For character bigger or equal to 0, yeah, because if we are, but we'll restart. Character will restart with the top one every time we find one. Yeah, so yeah, we have that. We started with the biggest, yeah, with the biggest, and we found one that's let's remove that condition. We found that one that's big. Yeah, but if it is 0, call this character as well, but it doesn't really matter. If character, yeah, if there's zero count, we just say that C minus minus and continue, please. That's fair. That's fair. So at some point it will hit in character that's not zero. That exists, yeah. And then we will need to check, yeah, if it hits the limit or not. But basically what we need to do, if we forget about the limit for now, by the way, we'll need to return string of result, yeah. Yeah, we now need to make result is append result, and we need to take this, turn them into byte, and C, this character plus, yeah. And by the way, we probably need to turn C into byte first. Yeah. Because C is an integer. I mean, it will be good. But now we need to introduce that limit. Oh, by the way, we put it, no, it's not good yet, before we do the limit. So we put it into the result. We need to say now that remove it from the current character count. And as long as it's not zero, we'll be just, yeah, we'll be putting them into result. What if, when we actually do that, we need to also track our limit. Let's remove that current. We're not using it. The limit is repeat limit. And we'll say that limit minus minus. And by the way, yeah, we'll need to restart it. When we actually move, so yeah, well, at some point we'll need to restart it. So let's say result, we put it, and we remove. By the way, we can do limit is 0, limit plus plus. Okay. We need to track this limit for this. No, the current C will be the one that's limited. Okay. No, right or wrong? So if limit, yeah, we go to the next. So we put, yeah, we move on to the next character only when we ran out of them, or Yeah, but if we hit the limit, if limit equals repeat limit, so it's 3. First thing we need to do, we need to also we need to restart the characters. We need to say character is now again at the top. But we need to skip the limit. We need to remember the limited character. Yeah. And limited character is byte is 0. Oh no, it's just limited character is 0. Yeah. We turn them into bytes later. So if we hit the limit, we need to update the limited character. Limited character is C, but C is restarted at that point. Right? Okay, now we know which one is limited, but we cannot append when we go through them again. Let's say we hit the limited again, and we restart the limit again. Yeah. Yeah. Restart all these things, reset. But yeah, then we go again from the beginning until we find something. But we need to skip. Yeah, if it's not, if it's 0, or if C equals limited character. Yeah, we also need to skip. And this way we might go to the, yeah. And if we found something to append again, we put that. If not, we just get out of it, and that should be working. Unexpected. Oh, append. Oh, append is a function. We were close. We were close, but there is some. Yeah, we're 1 hour, 10 minutes into this. So it looks like it's a good exercise, by the way, to do both problems. both problems at the same time. In one session, I mean, in one. That's a good exercise. Yeah, you get used to that. I mean, if you can do 3 problems in a row, you will probably be okay with 2. Yeah, once you get used to that, train your self to do that. Okay, what's the... yeah, it looks like it's working pretty well with a little bit of I want to see if format print line. Yeah, I mean, this might not be available at an interview, by the way. So to check the char count. So we have 4 C's, 2 Z, 1 A. Yeah, that's the char count looks right. Okay, limit starts with 0. Limited character is initially 0. I think we need to set it -1 because yeah, it might not affect in this case, but let's say if they were like yeah, if the initial, yeah, just so we not accidentally hitting it. This special. So character, we start with the highest character. And we go until we run out of those. And we pretty much, we just restart, go over those. Yeah, but first we need to check how we hit the limit. Okay, if not, then we check, do we have characters, yeah, of such, of these given characters. If we don't have them, or if they are the ones that hit the limit now, if we don't have the characters, we just go to the next character, to the smaller one. Okay, if we found, and it's not limited, we put it in our result. Result is append, we'll put that character and remove it from the char count. And limit is now 1 once we put it. And we do that 3 times, limit becomes 3. So how will our test go with that? So ZZ should be appended, and we ran out of those. Oh, we need to restart the limit also. Yeah, in that case, to restart the limit. Yeah, let's say we ran out. So we restart the limit, and I don't know if we need to move the limited character. It will be reassigned once we actually hit the limit. Yeah. So yeah, let's go again through the test case. So z appended, z is appended, limit is 2. Now we ran out of z's. We restart the limit, go to the next character, which will be c. Yes, c is, we also do that with c. Yeah, so we put those, yeah, we go over those c. Those c's 3 times, and we hit the limit. We restart the limit. We say that c is now limited. And we restart character from the beginning. Then we go, so when we reset, we check, okay, this next, oh, no. So this character, yeah, this, we reset, again, we reset. So this z is 0, so we're moving again to c, but c is limited, so we're moving to a. There is one a. We're appending a, and if a hits the limit, yeah, c becomes negative. But just because we ran out of a doesn't mean we need to jump out. We need to check if there's still something left. Yeah. So yeah, it could be, by the way, if we ran out of these or these numbers, we still need to, I think we need to restart again from the top. Yeah, we ran out of A's, but there might be bigger numbers yet, so we need to reset. We need to restart C from the top again. Yeah. But how do we do the search then? Yeah, it's not just like that, because yeah, we need to search from the top. The search from the top So that means, like, yeah, we were going over A's, and then we ran out of A's. We need to check if A's are and not only for A's, we for any, because the what could have been going, we were going like we hit the limit. We went to the, let's say we went to some number that's lower than the limit. We ran out of those. We don't go to the next one. We don't go to the next one. We go to the back to the one that's still, yeah, so this search might not be the perfect solution here. So we go to the next one only if we know there isn't anything higher. Then we go to the lower one. How to know that? How do we know that? How do we know that? How do we know? I mean, do we want to like just go over it again? If limited char, oh, it could be the limited char could tell us something. If there was a limited char higher than the current char, we need to go back to it. That's the thing. Yeah, so if character is 0, we go to the next one, but not necessarily. if our character right now so if limited character is bigger than char, then we say that character is limited char, yeah. If it's not bigger, so at some point, some character will become limited. And when it does, we're starting from the beginning. Just for simplicity. Yeah. Now, if we see empty ones, and the current character is not smaller than the limited char, if it's bigger, then we can work with it. Well, if it's, wait a second, if it's 0, yeah, so if it's 0, we basically move to the next one. And those cases are if the current character is limited, yeah, we need to go to the next one. If the current character is was higher, we need to go to the next one, yeah. Else was if it's bigger than the limited one, then the one that was limited, we go to the smaller one, yeah. But we need to update the so limited is updated when we find that limit. Each time we hit the limit, it's updated. Well, this will create like we were out of z's. Like, I don't know, we hit the limit on z's. Go to the next one. Z was limited, we just go back to Z's again and again and again. If we are in a zero situation, we change the character, we should say that the limited char. Oh no, we need to remember the limited char is somewhere. So limited char could be, we need to remember it, yeah, because we don't want to append it. We don't want to append the limited char. It's 1 hour, 30 minutes. You know what I think? I think it's a good exercise. And I think I have a couple of takeaways. So I'll try to finish this debugging. And I have a couple of takeaways for the next session. That might be helpful. Yes, I'll work on those. But one of the takeaways is it's good to practice like 2 problems in a row because it's closer to a real interview situation where what main dish problem. So it's good to do. Yeah, I think we should start doing that. Anyways, that's our practice session for this hour. My name is Alan. Thank you for watching. If you like these videos, please like and subscribe, and we'll see you in the next video.